Okay. That Therapy Boy Cat decided time for lunch. All right. All right. Welcome. Good morning. For anyone who is watching or catches the video and doesn't know yet, if you're new, my name is Tim. I go by Foamy Guy on GitHub and Discord. I stream usually around this time each week, working on stuff related to CircuitPython. If you don't know what that is, you can learn more at the main website for it, circuitpython.org. It is basically a version of Python that runs on tiny computers called microcontrollers. You can hook up electronics to them. You can write Python code, save it on there, and the microcontroller will execute your Python code and interact with other bits and pieces of hardware that you connect up with it, such as the BMP580 and 581 and 585 temperature and barometric pressure sensors, which is what I am working on the driver for today. If you happen to catch this and did not watch Deep Dive and you want the sort of prequel to this, you could go back and watch Deep Dive where we started the driver that I am working on today. As always, thanks to Adafruit for making CircuitPython possible. They pay a team of folks to work on the CircuitPython project, including myself. If you would like to help support them and CircuitPython, one of the easiest ways to do it is purchase hardware from them at adafruit.com, which is where the BMP 581, 580, 585 breakouts that I am working on the driver for came from. We are just diving right back in. One thing we're going to do today is bring over these enums, but I got to figure out how they should be structured, and that's actually where I'm going to start. Because we're going to need, so like really the next thing I want to do is get a reading recap yesterday on development with CircuitPython. We got the initialization working. But really the next thing I would want to do is start getting readings. And it looks like both get read at the same time based on this kind of. This code at least. Maybe inside of there it's two separate I2C reads. We'll have to go check that out over one. But in any case, it is likely gonna be involving reading calls, get sensor data. It's likely gonna be involving some more registers and some more configurations. Which are going to end up needing the enums, I think. This one's. I was missing one of the. That to be the. It pops up in and I can't see it. All right. Yeah. So I want to get some sensor data, but I have a feeling we're going to basically need some enums either to do it or if not, like basically right after. This was the driver I was sort of referencing yesterday, but I think this might not have. This has any enums like that. So it's got those constants. It's actually, I mean, like, looks like this one essentially is not using enums. It just has broken out individual constants for things that, sort of look enum-ish, especially compared to here. Like, most of this being used is right. So that's actually setting the 5 one back to the XX one. That's what all of these are doing. This is almost like just a rename. Okay. Okay. Maybe we won't use any kind of fancier enum or anything. Maybe we'll just use the constants and we'll kind of give them names that indicate which thing they're for. Pretty much basically the same way that this one. We will want like the actual values though. So these then are coming, I guess, from probably the H. Well, or maybe defs. It's like a constant wrapper. 8C, C for constant maybe. Okay. So maybe we just bring these over and if we'll need everything for here. Partway tempted to of Cloud basically, I mean, it looks like we want the 5XX naming. I'm tempted to have Cloud just like convert all those to Python for us. But truthfully, I basically really only want these ones, I think. For the most part, we're going to start with just the ones that are used sort of at the driver layer. oversampling, IR filter, ODR, reps. Like a lot of stuff, but not necessarily. There's an ODR setting, oversampling, IR filter. OOR, those are different. Those are. So why don't we start with these? All of those, and we'll kindly ask the version not mind convert to into on definitions. BMP5XX. It will just keep the last half of it, so I'm not gonna hold its hand through that. These are all unsigned ints, so you can tell it maybe to wrap the values in const. .40 starts at 0, counts up. Eyeballing it. Like it did anything too crazy. Beginning at least, that all looks good to me. Got a little scrunched. That is so looking correct. 127 is 706. Added the already had. Then it had some interrupt stuff. I'm gonna see how far we get without that. I'm gonna see if we can just go with this. Oh, getting driver. We had perform reading. Perform reading calls BMP get sensor data, passes in a address of struct data, which will get filled with temperature and pressure, and we'll need to remember to convert dividing. We need to see get sensor data again, which was in here. Which basically says that it's gonna read 6 bytes. Read registers X, temperature data X, significant length we saw last time, that's length, so it is reading 6 bytes. And then if the result was okay, so I don't think we really have the same concept of like if the result was okay, because we have the bus device things. I think we're either gonna get a number or we're gonna get an exception. We don't have like a intermediary numeric value. Not sure. It does get raw data shifted out of the 6 bytes, and then fixed point. I completely follow, but clearly it's gonna be like, I assume something to do with how much room is available to floats and stuff. This is forecasted on by that's a setting. Not sure. It does have this though, which set here. I clone this so that we don't have to have a million tabs open. It's not gonna stop me. Honest with it. Be more convenient because I can control click and find out what is in the variable. There it is. Yeah. I don't. It doesn't appear that that's ever. Or it seems like maybe it has some information that it. If fixed point is selected, then data return type is unsigned int 64 for pressure and int 64 for temperature. While for floating point, data return type is float for pressure and it's unclear to me who sets that, if that's like a thing you would do at compile time if you need it for some reason on the thing you're on, or if that's like a sort of driver user settable thing, or what. I mean, if def I think is a compile thing, right? Clear where that would be set if it were set, but it doesn't seem to be set, and therefore I think I'm just gonna go on the CircuitPython side with the else branch of this. Composite or component. I don't know if this person is watching. Eye on you too. Darth Paul. Darth Paul's a pretty cool name, my friend. I like that. I'm not a huge Star Wars fan or anything, but Darth Paul's funny. Composite or component is just an inherently better signal than RF, but there would be a lot more TVs out there at the time. I think this must be a reply to something earlier in the chat. So we basically, this is not really doing anything fancy. It's reading 6 bytes out of that register. It is shifting the bytes together to make raw data. It is using raw data for getting the temperature. It is... It's like you can enable or disable the pressure. So as long as the pressure is enabled, then it's gonna get a raw data P shifted out of the same register data that we read before, the same 6 bytes. This one only uses a couple of them. This one uses the rest. I don't know how many. 2, 3 looks like. I'm not sure. And then that will no doubt get used to calculate the pressure as well. And then we saw at the next layer up, the pressure does also get divided again, I think by 100 to get to HPA. Bars? That's pretty straightforward. We will want this register. And I think I am gonna make this XX now since we haven't used it. I think I'm gonna go back probably and add the XX on these as well. I'm not gonna do it right this exact second. So we do need to know where that's actually at. N? No, 1D. Copy. And then we need a struct. Need a struct, and we can. This will be. I don't think we want unary struct. Shift all this stuff out anyway. So if I'm understanding right, we need to read 6 bytes. 6 bits. Well, no. So I think then what it's doing is starting here, and that is the least significant bit of the temperature. I don't really know. Oh, extra least? I don't know if that's what that means, but it looks like there's 3 bytes in the temperature, 3 bytes in the pressure. So it is 6. And they are all sequential, so when it starts on this one and it reads 6 bytes, it is ending up with those things. Do we have do we have to read all 6? I almost think, why don't we read them? I mean, in CircuitPython land, we are gonna have these struct things. And if they're in different registers anyway, we're reading just different registers. I almost lean towards, why don't we just do temperature as one struct and then pressure as another struct. That way there's no need to like read both at once, which also kind of negates the need for pressure enabled as a concept, right? Because you could just take readings of everyone you want, and we're gonna have a property for each anyway. So if we do actually read all 6 bytes, then we're gonna end up, like, if a person does want both, then they're gonna end up rereading both twice anyway. Yeah, I think we do that. Three each, one for temperature, one for pressure. We do need to figure out though, what is that gonna be, because I don't know, our 3 bytes binary struct. Can I just do BBB for 3 bytes? I don't know if it works like that. So these are from register or bus device? What are these? Register. Oop. Slash. So we don't know until we try. So let's make a temperature unary struct that starts here, that is 3 bytes. And it can be read only because you can't write the text back, I don't think. I'm going to make it underscore temperature though, because we're going to want a property that's actually called temperature. That does, because the other thing is this still needs some like bit shifting, I'm pretty sure, to turn it into a real number. It is a number. Turn it into a number that represents the temperature. that it is typed as, so I'm not going to do it. RO struct registers this. And this takes the struct thing, so let's try goal triple B. And instead of init, it says reset. It does this. Let's tack on a print binary of self. Only got 1 byte. So another option, I guess we could do RO bits and we could specify 24. Oh, wait, do we need that? I think we might need that. Does that have... No, it doesn't. Just to read the bit from. So is there a thing that, I mean, there's probably not a 3-byte one. Is there a 4-byte one? I guess int is probably 4 bytes. Suppose we could do that, maybe? So let's do that then, I guess. So we're gonna read 4 bytes. So then the last 4 bytes that read are... So is this better than... I almost back to, why don't we just use RO bits, actually? Because if we read 4 bytes, then we essentially still have like the same problem I was talking about before, where we're going to duplicate the reads. We only duplicate 2 bytes worth instead of 6 bytes worth total, so it's not as bad, but it's still duplicated. Oh, unary struct is one thing, maybe. No way. Okay. That's, I think, the thing, actually. We don't need unary struct, we need struct. But we could use, like, read-only. Yeah, I don't like that anyway. It's going to map the 3 different bytes to 3 tuples. Yeah, I don't like that anyway. I don't want it to be writable, and I don't want to have to parse it back out of tuples. So what if we did read-only bits? Values are an int, so we know that ints hold 4 bytes. We should be fine there. We have enough room to store the data we want, and then we can just tell it 24 bits. Register. Oh, no. Number of bits is first, actually. Number of bits, then the register, then the lowest bit. 0, because ours are the lowest, least significant bit is first. Then register width, we will want that to be 3. It's even kind of the same. 24 here. 0, register width 3. For that. Okay. Okay. I mean, that's data. Sorta. Looks like data to me. So now we want to basically have a temperature property. We need to do this. Although this is like trying to treat I mean, this is just taking the 3 of them together, I think, isn't it? Oh, but it's shifting too. So one thing that's different is this says reg data 1, reg data 2, reg data 3, well 0, sorry, 0, 1, 2. But they have an array of bytes. So those are accessing individual bytes and then shifting altogether. I'm pretty sure that's doing what is done for us already. I think this is just shifting these values together to make one big number. We already have one big number, an int, in fact. I think we're done. I think this we don't even have to do. Because I printed it out as bits, but we could print it out as a number and it would be number. It does need still to be divided. So we decided this is not set, so I'm going to ignore it for now. Temperature then is equal to the raw value divided by this. So we want a temperature property. That's going to return a float. Now let's off. Back to here. Assume that's like we'll see it. Check that as well. A little on the high side, probably. Especially for self. Not quite right. Anything else happen above this? Pressure. Hmm. Does it change by lowest bit? The lowest bits index. Lowest bits index within the byte register. Oh, you know what? These are in the reset value, right? When we were printing, go back to printing the, maybe we need to enable it probably. I bet we need to like do something to get it to start working. Oh, cuz we're in sleep mode or whatever, right? We didn't yeah, I think when it comes up from a reset, it's in sleep mode or reset mode or whatever. Deep sleep mode. Yeah, so we have 0, 7 ones, 0, 7 ones, and then we actually have 8 ones on the last one. Different than the reset value. Yeah, I don't know why we have... Oh. Oh, it just truncated the leading zero is all. It truncated the leading zero. I think there is actually one there. And it truncated it. It's not like numerically relevant. Okay, so we have reset value. So I think we just need to get this to wake up. That block diagram or whatever of modes. I think after startup or soft reset, which we have done a soft reset at this point, it will be in deep standby. Transitions from one to another are only possible by entering standby first. Standby mode, no measurements are performed, power consumption is at a minimum, all registers are accessible for read and write. Most transitions to other modes are possible. Pressure and temperature data keep the values of the last measurement, which we haven't done. The FIFO we're not messing with. Also don't care. Okay, so deep standby, I presume, is the mode we're in. Well, okay, it depends if these things are true. I think we mostly want normal mode. Pretty much want normal mode. This is what pretty much normal. It's a low power normal mode. Whoa, interesting. Okay, and then continuous mode is as fast as possible. Okay, to go into standby, the status the user must write. To go into standby status. They mean mode, right? To go into standby mode? User must write ODR config power mode 0. Maximum transition time to standby is standby from the table. Effective status of the device is always observable by reading back the same register. But we should be able to read the mode register and find out which mode we're in, whether we're in standby or deep standby. I mean, I suspect, I guess we want to explicitly go to standby no matter what. Just in case we are in deep standby. I suppose we could check if it's true that we can check. So, into standby. ODR. In the our driver to see what it does for the. So maybe is this. It soft reset. Reset we did. Doing pressure enable. We didn't do any of this kind of stuff yet. Okay, there's the normal mode right there, in fact. Set power mode. So we do want to check, basically. So we'll have a mode property that will... The mode setter will access the mode getter and drive it to standby if it's not already. Then after doing that, right? I am predisposed to dislike switch case, especially when it's used this way with fall throughs. So basically for all three of these cases, we then do that. If the user asks to set to standby, then do nothing because we already set to standby up there. Okay. Okay. So let's get the mode register. Eight. It's wait, what are the power mode? So that's 0 through 5. Confused about why it seems to read a byte and then picking at literal value for the name of this function seemingly only get bits position. Oh, get bits position, and then okay, so this is going to be how many bits to get, which is 3. Well, no, that's math. It does say 3. Clear. Know where that comes from. That is weird. Maybe it's referencing mask, even though it doesn't say it. In any case, I do think it's getting 3 bits. So we want an RO bits of 3 on Mr. ODR config. Seven. It's and then I guess though, do we want it says 2. Makes the 0 be 0 0 make more sense, but then why how there's 5 modes. how can there be 5 modes if there's only 2 bits? Plus 4 permutations. Where was the comment that said 0? There it is. 0 through 4. Standby doesn't exist. Standby. So for deep standby, you can't go to it explicitly. You always wake up in it. So if you want to go to deep standby, you just reset and make sure all those conditions are met. Internal API. So it does get data 1 byte from the same register we're looking at. Setting deep dis equals 0 enables the deep standby mode. Okay. Deep standby and standby are the same mode. Okay, I think I understand the datasheet more. Deep standby and standby are the same mode. If you... Okay. Is why they're in the same circle. So basically, when you're in standby, if these things are all true, then you get to go to deep standby and it just happens, seemingly. If any of those things change, you go right back to standby. Okay. So we only want 2 bits. Is it least int? It's register address, lowest bit 0, and then register width defaults to 1. And just 0 and bits for. So for a mode getter, it's actually easy. You're in mode 0. So you really know if you're in deep 5. I mean, you could look at, you could check that you're in standby, and then you could check all those other factors. And if you know the rules on those other factors, and if all the rules check out, then you could discern that you're in maybe. I do want mode. Does it default to numbers? Maybe it just defaults to numbers. So if you do enum, to numbers. A new setting this. I guess they're going to be numbers. Because that would make sense. 0, 1, 2, 3, 4, and then deep stand. Well, 0, 1, 2, 3, and then deep standby would be 4. Yeah, yeah. Okay. Okay. Yeah, yeah. I don't care. I'm not really asking you about so much as the C syntax, and I believe based on that I get it. Those are numbers. So I would like them to be not just implicitly defined as numbers like that. Instead, we will explicit. So we will. And can you please define Python Actually, the other one should be primed. This. Say, can is do the same for these, right? Because it will know these are supposed to be numbers. The other tab did. Nice. Oh. Oh, okay. Yeah, we wrote a bunch of it. Friend. Okay. So, we're setting the mode. Mode setter. Done. This is technically an int, but realistically it's like a literal one of these four. Well, 5 maybe. I'll call it an int for now. And what we'll do is we'll say if new mode not in set of all four. A normal first. Right. Not in that, then raise. And then we check the current mode, and if the current mode is not standby, then the very first thing we need to do is set it to standby. What this does as well. Get the current mode, store it in register data. Table. Okay, this I don't necessarily know. I thought, did we not see where? Where we saw somewhere where it said like. Yeah, okay. Where was I? Around now. So set power mode. Maybe I was in get power? Get power mode. I don't know. In any case, this one is actually set. It's going to get the current power mode first. Calling it last power mode, I guess. LST last for like previous. And then if it's not in standby, the next thing it does is set it to standby by calling it. Okay, that's where I was. There's a BMP5 set power mode and there is a set power mode. Get it if we're not in standby, set to standby, then delay by that amount. then set it to the desired mode. I'm going to worry about these three first and deep sleep later. Okay, so set power mode then is where the actual register gets written. So it reads a full byte. It sets deep disabled. Disabled is here. That's deep disabled to 1. Copies. Disabled is the there. So presumably that's setting that high bit to 1. I don't know if we'll need that. If we do need that, then we have kind of an issue because right now we're only reading those last 2 bits. We're not doing a full byte like this one is. So I'm gonna make a bit for deep disabled. We'll check the value of it. And we'll then go from there. I guess that's that's where our last bit comes from, and it just behaves differently because it's got all those other rules too. Deep, what do they call it? Standby? Little bit. Ah. Address and the bit. Register which. Register width. Ooh. Okay. So we are we are in deep sleep, deep standby. So we do need to mess with this, but now we have that thing. So this should be so these should be writable. First of all, we made these both RO, and we actually want them both to be RW. Mode, this should be RW, and then deep disabled. This should also be RW. Bits we don't have. Grab it. And so now we can write them. So that is setting that explicitly to 1. I don't know exactly how it gets that, but presume that that's pointing it to the bit index number 7. So in our mode, we can just go self.deep disabled equals true. Then it's also setting the power mode 2 bits. So we have already validated that our power mode is 2 bits because it's one of these values, which are the only 4 values for 2 bits. So then we can just go self mode equals mode. It has to put into register data and then write back out as a full byte, and then it returns. Okay, so theoretically, we should be able to go to mode normal and start getting actual readings. Let's go bmp.mode equals hey, that looks more like room temperature, I think. Hand's kind of cold. I was going to say if I put my hand by it, we can see it respond. But honestly, my hand's kind of clammy right now. Oh, but it definitely went up a bit. Going up, but it will... have a, I was gonna get a soda a while ago. Let me get a soda, which will be cold. Yeah, nice. I drove it way down by putting it next to this cold can that just came out of the fridge. Okay, and then I'll check one more thing. Well, how do we convert C to F times fifths plus 32 times 9 fifths. Yeah, and that's probably basically, that should be... In fact, I make it out all the way, but honestly, it looks like that agrees with what the thermostat says. Nice. All right, let's turn off the bits. We don't need that anymore. There. We should do that delay thing, right? I didn't put the delay thing. 2 milliseconds is pretty fast. Or do we need it longer than 2 milliseconds? Because that one thing said standby. Was that different than... I want that table that said like T standby is equal to how many milliseconds ever. So the delay was in the high. So there's 2 layers of this. The delay was in BMP5. Delay microsecond. That is 2.5 milliseconds, I think. 500 US to... We should do that. Honestly, it's somewhat likely we have that amount of delay anyway, but in our case, we were already in standby, so... Did we even do that part? No, we didn't. Okay. So we actually, yeah, I skipped that whole thing. So we need to say old mode. If old mode is not standby, then we need to put it into standby. Which I don't think we want to make this like recursive. I think what we do is just mode equals standby. That's basically all this does. Get the old mode. If the old mode's not standby, then call this lower level function. Duplicate it in an... Do that and then send this back to it. Want the lower level. Register sets the deep thing. So we should do that part. But then that's basically... Do this in here also. So set deep disabled to true. The mode is not standby. We want to take it to standby. In order to do that, we're going to go deep disabled true. Mode is standby. That's where we want our sleep. They did 2.5, so I guess I'll just keep it the same. I think I made up the 6 yesterday. Today we're keeping... nonetheless. Old mode is not that, then do these things. Otherwise, or afterwards, then we turn deep disabled to true at the new mode. Okay. Should be able to go like back to standby Let's make sure. So the current time. The current time -5 is greater start time. That means 5 seconds have elapsed. We almost don't even, which I guess it does, right? So set power mode even says this one. Yeah. I guess we can have that as well. So this is going to set it to standby. So we could basically say if the new mode is not standby, then we do this. Because if the new mode is standby, then we already actually changed to it. And in this code, that's represented here with this case block. If it is standby, then we just break out of this. Don't do it. I guess we could return instead if we wanted to make the logic. Okay. So here I want after 5 seconds. Then so if you're already in standby mode, then you will not go in here and you will return. So yeah, if you're already in standby mode and you ask to be put back into standby mode, we could actually make this ever so slightly. No, we can't do that. It has to be here. Yeah. Okay. I was gonna say we could get rid of the read, but that's not actually true. Put this like this. After 5 seconds, put the mode to standby. So we should get 5 seconds of real readings and then locked onto whatever the last value was. By the can, but I'm going to take the can away. So theoretically, it would start chunking its way back up to the low 76s because the can is gone now, so it should go back up. But it is in fact stuck on B508, meaning we made it back to standby mode, and that standby mode correctly stops the readings. Sweet. Okay, so got kind of over the hump of get it to do its main thing. So I'm actually feeling like this might be a pretty good stopping point for now. Because I'm pretty happy to get actual real temperature data out of it that looks accurate. And it seems like getting pressure data is going to be super easy. Because all we will need is to make another one of those. Another one of these ones. We'll need a different divisor here. But otherwise, pressure looks pretty easy also. And then at that point, the things that remain are all these settings. And in fact, some of those settings get done inside of begin over here, I think. Saw that earlier. Was initializing those to whatever their defaults are. I have not done that yet. So we may be like this stuff here. This is in a init, which gets called early. It's setting temperature oversampling rate to 2x, pressure oversampling rate to 16x, ODR. I don't know what that means, but it's setting at 50 hertz. Pressure enabled. True, I'm guessing. We will want to look, is this, I mean, I think this is like at the C code. Is this at the C code level, or does the actual driver, like, does the actual chip have a concept of pressure enabled? Yeah, it does. There's press enable right there. Okay. Okay. So we'll need to set that up as well for pressure. That's set to true if it's not. But otherwise, pressure should be basically the same as temperature. Then the configs shouldn't be too hard. The configs should just be figuring out the right bytes and bits and registers and filling in the unary structs and stuff we need. So, feeling pretty good. All right, I'm going to head out for now. Thank you to anyone and everyone that has watched along. I hope you enjoy the rest of your day and your weekend. If you're in the US and you happen to have a long weekend, then enjoy your long weekend. If not, my apologies. Hope you enjoy your weekend nonetheless. Oh, what's up? Or was this from yesterday? This was from yesterday. Yeah, okay. I thought it was like it's the chat very end, but no. Okay. Yeah, I will be back for deep dive next week, as far as I'm aware, on Friday the 5th, 4 p.m. Central, 5 p.m. Eastern, 2 p.m. Pacific, and then I should also be back on Saturday next week here on my channel, 10 a.m. Central, for some more CircuitPython fun. Until then, farewell, so long, see you later.